So the real-time web is something that I've been working on for, I don't know, 4 or 5 years now. This idea that the browser can be a two-way communications channel with very low latency. So I'm going to show you guys explain how we do this stuff with XMPP and this JavaScript library. I'm going to show you guys some code and some demos and stuff like that. So XMPP is the protocol that we sort of use to make this magic happen. It's one of a couple of choices that you guys have. It happens to be my favorite. It stands for the Extensible Messaging and Presence Protocol. It was initially started in, I think, '99 by Jeremy Miller and some friends to sort of take on the closed instant messaging systems of AOL and Yahoo and those guys. How many people in this room know about XMPP or have used it? So quite a few. So everybody who has a Gmail account and didn't raise your hand, you know and love XMPP already. So it's originally intended to be instant messaging replacement protocol. It can be used for pretty much anything. It can be extended, and people have done extensions for publish subscribe semantics, for ad hoc commands, XML RPC, pretty much anything you can think of. Someone's written a spec for how to do it over XMPP. These days, it's used for a lot more than just instant messaging. And in fact, most of the applications that I write with XMPP have nothing to do with instant messaging. So why do we want XMPP? Well, probably everybody in this room does most stuff with HTTP. And HTTP APIs are great. You can do a lot of stuff with them. REST APIs are great. You can do a lot of the functions that you want to do. The problem is that HTTP polling really sucks. If you want to get the latest Twitter updates, you have to ask Twitter, hey, is there anything new? And then you have to ask them, hey, is there anything new? And like 95% of the time, there's nothing new. But if you want to get low latency and actually have a conversation, you have to do all of this polling anyway. There's no really escaping it. And so real-time applications are different. They require you to have this low latency, which in the HTTP world means you're polling the crap out of something. And XMPP is sort of a good solution to this. Where HTTP is stateless, XMPP is stateful. It has a long-lived TCP connection under it. And so you're probably all asking, because of that, how do you do this from the web browser? So before I get to that, I want to, for those of you who probably never seen the actual protocol before, I just wanted to go through a couple of the protocol points. So there's an XMPP network. The network is federated in an open way. It's very similar to email. You have a client. It talks to a server. The protocol that they use is called the client-to-server protocol. It's very creatively named. And of course, you can have lots of clients talking to the same server. You can have two servers talking to each other. These speak a slightly different protocol called the server-to-server protocol. And of course, lots of servers can talk to lots of servers, and each of these servers can have thousands and millions of clients hanging off of it. And it works like email. So if I'm on this server here and I send something to server B, it's going to forward the message to server B, which will forward it on to the user there. Unlike email, there's only one hop here. So I go directly to the pure server. I don't go through any intermediate nodes. And there's no forgery possible, meaning that if this, the server can forge local users, but nothing can forge an arbitrary user on the network. So if it came from a server, you know that it came from the server. You don't have to worry about some of that SMTP spam vector stuff. So to get all this data shuttled around, we have an addressing scheme. It looks a lot like email's addressing scheme. This is a domain. This is probably the simplest XMPP address you can have. This is an address of a server in most cases. You can have user at a domain. That looks just like an email address. We call this a JID for Jabber ID. This is called a bare JID because it's just the user and the domain. This is called a full JID. We have a user, a domain, and a resource. And we need this because you might have multiple connections to an XMPP server, and they're disambiguated by this resource bit. So for instance, my connection where I'm at home might be called home, and I might have one for work. Gmail likes to give really random strings as these resource identifiers. It really doesn't matter what they are, as long as they're unique. So the protocol, it's based on XML. It uses something that most other XML-based things doesn't, which it uses XML streams. Essentially, this means you have two XML documents that are built continuously on the fly, one in each direction. Over these, so for instance, when you make the connection, you open up the root element. You send these messages across as first-level children, and when the connection is terminated, you send the root close. So at the end of an XMPP connection, you'll have two completely valid XML documents, but during the XMPP connection, you work with XML stanzas, which are these first-level children. So there's three main types of these first-level children. The first one is message, and we have presence, and we have this weird IQ one. And IQ one stands for information query. This is pretty much exactly equivalent to an HTTP GET request or an HTTP POST request. It's the only one that's required to have a response. So message stanzas. These are the basic building blocks when you send messages back and forth. They could be chat messages. They could be arbitrary bits of data that you're sending around. This is pretty much what a normal chat message would look like. You have a from. In this case, the from is always going to be a full JID, unless it comes from a server or something. You have a to. That's where you're sending it to. You can send it to a bare JID. You can send it to a domain, all kinds of stuff. And it has a type. Most of the time, this is going to be chat for private messages. It might be group chat for group chat messages. There's also some other types like headline and things that are used for various weird purposes. And then we have the body, which just has the text of the message you're sending. And of course, if you're sending a message that's not chat, you might not have a body. You might have something else here. Presence is how you know somebody is online or away or busy and that kind of thing. In XMPP, we use it. It's sort of a mini publish-subscribe system. Here's somebody setting their presence to away. We have type equals away. There's also, if you have no type, then it's type equals, it's basically available presence. There's also do not disturb and some other ones. And then the show is it's not arbitrary text here. There's only a few possible parameters, and that's just to give the client developers something, a hint at how to show this presence. And then the status is just free-form text you can put. This is like Facebook status messages or Twitter updates, that kind of thing. And one last thing on presence is that you have to subscribe to people's presence. So for instance, if I want to add somebody to my, we can't say buddy list because AOL has trademarked that name, so we call them rosters. If I want to add somebody to my roster, I send them a presence subscription request, and they can approve it or deny it, and then I can see their presence. And these presence are two-way, just like Twitter follows, which means I can subscribe to you, but you don't have to be subscribed to me, or we can be mutually subscribed to each other. So IQ messages look just like this. There's a to just like everything else has. We have a type equals get. There's also a type equals set. Get is sort of like a HTTP GET request, and set would be more like a post. So this is generally used when you're accessing some information as opposed to changing some data. Every IQ has to have this ID attribute. They have to be unique for the stream. And this is because when you get a response to the IQ, it has to have the same ID attribute on the response. And then a lot of the different protocols in XMPP use this query child. And then this namespace here, I've shortened them, so these aren't quite the real namespaces. Tells you which sort of extension protocol is in use here. This one, for instance, is service discovery. Here's the response to that same IQ that would be sent from the server. You can see that we have the same ID there. This is type equals result because it's a response. We could also have a type equals error if something went wrong. And we have the same ID as I said. And then this is all of the answer stuff. So we did a service discovery queries, and this is the service discovery result. It's telling us about the identity of this thing is an eJabberD server, and it has these features, and usually there will be a giant list of these for an XMPP server. Various different objects on the XMPP network will respond to service discovery queries with different things. So now we get to this point where we want to integrate XMPP with the web, which is kind of a challenge because, as we all know, the web is stateless. and it's only one way. Well, I mean, we can only ask in one direction. We can't ask in the other direction. So there's a lot of sites that have started using XMPP on the web. These are a couple of them. These sites are, ChessPark is a site that I built. The other three are not. All of these sites use the library that I'm about to show you. Dropio uses XMPP. Every collaboration zone in Dropio is a multi-user chat room. So when you drag a file into the browser to share with your friends, it actually sends a message to the group chat room, and everyone in the collaboration space will get a message, XMPP message saying there's a file dragged there, and that kind of thing. Presently, and Yammer both use it for real-time updates on the site to keep the home pages dynamic. And XMPP on the web is sort of made possible through BOSH, which is bidirectional streams over synchronous HTTP. And this is a really fancy name for long polling. So I don't know, how many of you guys know what long polling is? So a couple of you. So this is what long polling and normal polling look like. In a normal polling situation, the top line here with this red stuff, the very top of that is the client side. So the client makes a request, sends data to the server, hey, is there anything new? The server responds immediately, there's nothing. And then we wait for a while, maybe it's a minute. Then we send another request, hey, is there anything new? And you can see this keeps happening over and over and over. Long polling turns this exactly around. So now we send a request to the server, hey, is there anything new? And now the server is smart. It says, well, there's nothing new, but there might be soon. So I'm just going to hang on to the result as long as I can. And that way, if something new comes in, I'll just fire it back with the new data. If nothing new comes in, after some time, like maybe a minute or so, I'll just fire it back empty. And at that point, the client will re-request, and it'll sit there. So in long polling, you have these long periods where the request is on the server end waiting for a response. And this allows you to do two-way communication pretty efficiently, about as efficiently as you can do anything over HTTP like this. It's the client's responsibility. So for instance, if you send a request and you wait for a while, and now you need to send data to the server, when you send the new request, the server will release the old one, because you only have 2 requests available in most browsers, so we have to keep jumping back and forth between them. So BOSH uses this bottom version of it to enable it to have two-way low latency communication. And now we get to Strophe. So before, was there a question? Okay. Before we get to, what? I didn't hear what you said.
Works like comments? Long polling. Comments.
Comments? Oh yeah, it's like Comet. Yeah, sorry. Comet and BOSH are similar technologies. And people have written long pollers that don't do Comet or BOSH. They do custom protocols. The CouchDB team is working on such a thing, for instance. So here's some examples of things. This is a group chat application that my team wrote that uses this. I hope I'm still logged in, but you can see I can type stuff and it appears instantly. We can log in and do all that kind of stuff. This is my presence up here. These are the other people in the room, so they can talk back. So you can see the latency is pretty low, because I'm actually waiting for the server to send me the message that I just typed to show it on the screen. This is another application we wrote, ChessPark, where you can play chess games. The most popular speed of game on this service is all the moves in 1 minute per side. So we had to get it extremely low latency for this to work at all. And maybe I'll give it a second to see if it loads up really fast. So you can sort of see how dynamic the initial interface is. So this is a full XMPP client. We have the roster over here on the left. The private chats and group chats will load here on the right. This middle list is games that people are actively looking for, and it will be changing the whole time we're looking at this page. Like there's 2 just disappeared because they started. We can watch games and all kinds of stuff like that. So this site is incredibly dynamic, and it's using the APIs that it's using are XMPP right in the JavaScript. So we're building XMPP protocol messages, we're sending them. It has latency characteristics similar to a desktop client. And as far as the developers are concerned, they don't ever see the the long polling bits of it. It looks like a real stateful XMPP connection to them. And so I'll get into the Strophe. So Strophe is the library I wrote, the JavaScript library I wrote to make XMPP in web browsers possible. It's mostly for writing XMPP clients. You can't really write a server with BOSH and the browsers. Well, I don't know why you would want to, but even if you wanted to, it's not really possible with the protocol. It's in pure JavaScript, although I'll probably integrate your project over there, Flens, so there might be an invisible flash thing, so we can do cross-domain stuff really easily. And we made it to power real-time web applications where there's lots of collaboration and dynamicism. It's fully documented. The whole library has documents even for internal structures. So if you're not sure how something works, you can just look it up. And it's highly optimized. And what I mean by this is not necessarily that this is the fastest XHR implementation on Earth. I mean that there's a lot of edge cases in XHR when you're doing lots in XML HTTP requests, when you're doing lots of these requests. Meaning the XHR object only understands HTTP error codes, for instance. So it knows if you get a 404. It knows if you get a 500 error. If your proxy server drops the request and never returns any data, it doesn't know what to do about that. If the server never returns anything, it doesn't know what to do about that. So Strophe is highly optimized in the sense that it will detect if we were supposed to get data back and didn't, because if you don't time out and do fancy stuff like that, your low latency dreams will be smashed to bits, because you'll be waiting like 9 minutes for the proxy server to time out on the request response, and the whole time the user can't do anything. So there's most of the grueling parts of Strophe are all error handling of XHR stuff. And it's been well tested. We've used it on ChessPark for about 3.5 years now. It works on the Wii, it works on the iPhone. I mean, it literally works pretty much anywhere. There's a couple of people now doing Adobe Air apps that use that use Strophe. We built it for ChessPark, but it's an open source project. We use it to power stanzas, which is now Collecta, which is a real-time search engine that I work on, and Speak, which is the group chat application I showed you guys. And a bunch of different companies use it. Neuros OSD uses it to put in chat where the subtitles go in TV shows. So you can chat with all the other people you know who have Neuros OSD boxes, which is probably not very many. So let's actually build something, or at least see how something is built with this library. So first we have to manage the connection, because each XMPP thing has a connection. And we have to do a connection. So we just do var connection equals new Strophe connection. And this URL is going to be the URL of the BOSH connection manager. And normally this is, just someone will tell you what this URL is, or you'll set up a BOSH connection manager and you'll give it the URL for that. Once you have this connection object, you can call the connect function and pass it the username and password. And there's also a callback. And the callback will get called whenever the connection state changes. If you pass in a username like user@domain, then the server will give you a resource. Like we saw those earlier, so every connection has one of these. You can pass in a resource and it'll use that one. Or you can do what's called SASL anonymous authentication, which means you sort of log in as a guest. You have no authentication credentials. You don't need a username and password. You just log in with the server or the server and the resource, and you'll get an account and you can interact with the server. We use this for applications which we don't have user credentials for, or for instance on Speak, if you first come to the site, we log you in anonymously and let you use the service without having you sign up. And then later, if you sign up, you can upgrade your connection to an authenticated one. The connection callback just reports the status. So whenever Strophe, it'll attempt to connect, it'll attempt to authenticate, it'll have connection errors, and each time one of these states happens, the callback will get notified that it happened. This is all the normal stuff that you would expect. The main one that you want to work with is you're sitting around waiting for the connected state, and then you can actually do some stuff. And this is how you would do that. So this is the callback handler that I would pass to connect. And this one's really simple. It just waits until I get the status connected, and then it does some stuff. And I don't have the stuff that it does in here right now. But usually you would send initial presence to the server, so you would tell the server like, hey, I'm actually here, and you would do queries for your roster and stuff like that if you were writing an IM type client. And then we need to be able to send data. once we're connected. And now we can just call connection send, and we have to send it XML. And the reason we send it, these are actually DOM objects, and the reason we do that is if we send invalid XML, for instance, if we craft it by hand and forget to escape something, then XMPP will just drop the connection. So we don't allow the user to do that. We make them give us nice XML, and that way we don't have anything to worry about. And I'll talk about some about building that later. And then disconnecting is really easy. We just call disconnect. So that's pretty much all of it, except for handling events. So XMPP is all about being event-driven, just like most UI code. And we have interaction events. We have timed events, and we have stanza events. Now, interaction events are sort of like when a user clicks on a button and you need to do something to it. So for instance, if we have a send button, the interaction event gets called, and this is just, I'm using jQuery here as an example, but this is possible in any of the libraries pretty much. You build a message stanza, send a message, for instance. If you have stanza events, that means that you set up you call this function add handler, and you tell it what kind of stanzas you're looking for. So here we're looking for a message stanza of type chat, and whenever the connection sees one of those, it's going to call onMessage, which is just a callback function. And this is what that callback function might look like. It gets passed in the message DOM element, and we can do whatever we want with that message, like for instance, extracting out the message body and displaying it on screen. And then we return true, which means that this handler will keep getting called back. If we return false here, then the handler will sort of disappear. So if you were doing a one-off handler or something that needed chaining, you might return a different value there. And then IQ stanzas, which we talked about, which have to have results, are another good example of when you would have a stanza handler. If you're answering, if someone sends you an IQ stanza, you're required to return a result. And the way you would do that is you would just listen for IQ stanzas. So for instance, here is type equals get, and the sort of the extension protocol thing they're using is Jabber IQ version, which is actually the thing that you use to say like what version of the client software are you running. So someone might send you this just to see what kind of features you support. And then the other side is you'll send an IQ, and you're going to expect a response that you have to watch for. And so here we're still watching for IQ messages. We don't care about what the type is, because remember, this might be result, it might be error, and we're going to handle both of them here. And we know that we want to handle this disco1, because normally what will happen is you'll create a unique ID, you'll send out an IQ stanza, and then you'll use that unique ID here in the handler to handle the message. And then timed handlers are this is just a silly wrapper around set timeout so that everything's consistent. And you guys can use that one, or you can use jQueries or whatever. At the time that I originally wrote Strophe, there wasn't a jQuery, so that's why some of this stuff ended up in here. And then building stanzas is sort of the last bit. So I made this thing called Strophe Builder because working with the DOM API is sort of gnarly. And this is inspired by jQuery. It always returns a Strophe Builder, or almost always. So you can do this chaining like people are familiar with jQuery. And this is what it looks like at the basic level. So you have a stanza, and you call Strophe Builder, you say message, you pass it some attributes, and that'll build you a message. And all the methods are chainable, like I said. So for instance, you can add a child to the DOM with a name and attributes, just like we did there. We can add a text node very easily. We can add pre-made children. So for instance, if you have an element already that you received and you're just plucking out some bit of it and putting it back in, you can use CNode. And you can modify the attributes. This is really useful if you have something that builds basic stanzas and you just have to put a new to attribute on it or something like that. And we have a thing that traverses up the tree. So when you add a child, the next child will be a child of that child. So it sort of goes downward. So you need a function to sort of go back up the stack so you can make siblings. And here's some examples of how it works. This is building a message very similar to the one that we saw earlier. So we create a message, we send it to somebody, it's type equals chat, we create a child of type body, and within that child we create a text node of hello world. Here's a slightly more complicated one. This one is the same as the one we just saw, except that I go back up the stack and I make an HTML child, which uses the XHTML-IM specification, which is a way to send HTML messages over in your XMPP messages. And then I make a body tag and P and have hi. And then there's a bunch of convenience functions for Strophe builders, because typing new Strophe builder is a pretty long thing to type. So we have $pres, $message, $IQ, and these will make the 3 basic XMPP stanzas along with their attributes without having to do any extra work. So this is the shortest Strophe builder thing that you can do, $pres, parens, and that's the shortest valid XMPP message you can also send. Here's the same message that we originally saw, like the hello world one, with the body and XMPP rocks, but with this convenience function. And now we get to the unchainable methods. And there's just a couple of these. We have toString, which serializes the DOM element to a string, so you can see what it looks like or print it out somewhere. We have .tree, which will return, it's sort of like jQuery's get. It just returns us the actual top-level DOM tree. And that's it for the unchainable ones. So let's look at an actual application that uses this stuff. And first, I'm just going to show you the application. So what this application does is I'm going to type a server address in here. It's going to connect to an XMPP server. It's going to ask it what stuff it supports, and then it's going to print it all out to us. And we'll get to see what that looks like. So I have an XMPP server running on localhost. I hit connect. And here it is. Here's the answer. So it's pretty simple. This is just a list of features that it supports. It's got a lot of pub sub stuff on it and stuff. It's an eJabberD server. And then this log tab shows us the actual BOSH protocol that got sent. So for instance, this one right here is the initial BOSH thing that sets up the connection. And then there's a bunch of stuff for authentication that's not really that interesting. And then down here, you can see the IQ stanza that we created right there. A GET request to localhost with disco info. And then this next one is the server's response. And as soon as we get the server's response, we disconnected, and you can see it disconnected. And then the code for this is really simple as well. So this is the code for this function. So this is all using jQuery. So in the ready function, I use jQuery UI to set up the tabs, and then I hook up the connect button. The connect function is right here. Can everybody read this? Is it big enough? OK. So we prevent the default events. We create a new Strophe connection. With this raw input and raw output are logging functions. So that's what generated that XML. Strophe will call this whenever it sends or receives anything over the wire. So you can use it for protocol debugging. We grab the server out of the form field. And then we call, here's the connection.connect function. Since we're just making an anonymous connection, we don't need a password, so that's why that's null. And it uses onConnectEvent for the callback. OnConnectEvent is right here. And here it's very simple. We only handle 2 states, connected and disconnected. And disconnected, all we do is print out some stuff. In connected, we add a handler for this IQ result that we're looking for. And you can see here that I don't actually say IQ anywhere because we know it's going to come back with the ID. So all we really need to check for is the ID. And here you can see I'm looking for the result, so the error case is totally not being handled. You might have a second handler for the error case, so the logic's simpler, or you might do them both in the same handler. I find it's usually better to get as specific as possible with the handlers. And then I build the IQ stanza, and then I send it out. And so once the result comes back, if an error comes back, nothing will happen. If a result comes back, this onResult callback will get called, which is right here, which is the longest function in here. And this basically just writes a bunch of stuff to a special div. Here I'm using jQuery to parse out. I'm getting a DOM object back from the handler of the IQ. And jQuery makes it really easy to chop this thing up and rip stuff out of it. So I grab all the identity nodes, which are one of the things it returns in service discovery. I build this little table, which has a bunch of that stuff. Here I find all the feature elements in that result. And I build a little list of feature elements. And then I call connection disconnect, and we disconnect, which we all saw. Does anybody have any questions on that? No?
Is that the callback that runs when you receive the IQ response, right?
Yeah, when you see the IQ response, this function gets called. And it's really easy. I mean, all I do is use jQuery to pick stuff out of the DOM element that gets returned, and then I write a bunch of HTML there. Obviously, if you are having, like, the chess park stuff has a lot of different handlers for different cases. So we have handlers for when a private message is received, for when a group chat message is received, for when game moves are sent, for when you send game moves, and all kinds of stuff like that. So and so the handlers, you'll have a bunch of them, and some of them you'll only use once. Like, for instance, this IQ handler right here, we only use it once. So here it returns null, which is a sort of equivalent to false, and this handler will go away afterwards. Because we're never going to get another IQ result that matches this, because it's going to the new IQs have to have unique IDs. So there'll never be another one. So plugins. One of the things about XMPP, it's very extensible. You can write new bits of stanzas and just stick them in there. So for instance, at Chess Park, when we wanted chess moves in there, we just made a special namespace for our chess stanzas, and then we put them in messages. There's a lot of extensions defined already. Just to show you guys the number here, which hopefully won't scare you. You know, there's a couple hundred of these extensions for all kinds of things. Some of these are used a lot. Like, for instance, multi-user chat is one that's used a lot. Service discovery is used a lot. And there's some that are almost never used, like SOAP over XMPP. Only a few crazy people are using that. But this list keeps going. So for instance, I mean, there's stuff in here like Jingle is for multimedia conferencing with SIP. One of the nice things about XMPP, if you have some crazy use case, you don't actually have to design all the protocol. You might have to write the code that supports this protocol, but you don't have to think of all the edge cases that can happen, because there's a giant group of people that sort of works these out for you. So in order to support all of that stuff, like Strophe is very simple. You've seen that it only has like half a dozen functions. And yet there's this whole page full of extensions that people do. So I wanted to have a way for people to do plugins. And the plugins would be things like it would handle the SOAP over XMPP stuff, and it would just give you a simple function to call to do that, like SOAP send. Or with publish subscribe, you would want to just do subscribe. You don't actually want to have to build the IQ message that gets sent to the server that does the subscription and handle the error cases. And so the plugin infrastructure just has two functions. You can add namespaces. These are, as I said, these are the things that sort of define the extensions. So each extension has to be namespaced. This is, for instance, the XHTML IM namespace, and that's actually the full namespace there. So your plugin can add new namespaces that you can use, so you don't have to keep writing them. And it has add connection plugin. And you have the name of the plugin, and you just pass in an object. And what will happen is your connection object will get a new attribute, which would be my plugin in this case, which will get initialized whenever your connection is initialized. And so you can have all of your fancy functions like subscribe and stuff in this object. And I wrote a little Identica. Who's here's familiar with Identica? So Identica has an XMPP bot that will send you microblogging messages, just like Twitter used to have and got rid of. So I wrote a little plugin to show you guys that essentially is an Identica client, a very simple one. And here I'm going to use my Gmail credentials to log in to Gmail, because that's where all my Identica messages go. And you'll have to forgive me because I'm typing my long password with one hand here. So we connect, and it'll take a second because the wireless is a little slow here. And then it'll switch to waiting for messages. And then there's a handler here that whenever an Identica message comes in, it will add it to this list here. Okay, so we can look at the log file and see what it's doing. So we can see that it's still going through the connection stuff. There it finally connected. And here's a bunch of stuff that happens when you log in. This is all of the people in my roster sending me their capabilities so that I can see if they have music information they want to share with me and stuff. And so now it's waiting for messages. So now if I go to Identica and I type something, Even this is slow. So in any case, it will appear in there. You'll have to trust me, I guess, because the Wi-Fi is not behaving. And we can also send messages from here, like those interaction events I talked about before. And we hit send, and it'll actually build the stanza and send it. And of course, since Identica is apparently being really slow right now, it'll take a while to show up. And I can show you the code for this. Oh, there it is. So it shows up there. And this is actually using XHTML IM. So this is actually a clickable link that will go to my profile page. And the code for this is just barely more complicated than the code I just showed you. So we have almost the same on the connect function. So when we call connect, we set up the connection in the same way, except now we have a full username and password. We call on connect event as the callback. When we connect, we send initial presence, and then and we write that waiting for messages thing. And we have, there's a missing handler here that I accidentally deleted. So in this onConnect, the first thing we would have to do is set up the handler that handles messages coming in. And for some reason, I deleted that right before I walked up here, which is crazy. And then here's the stuff that happens when the handler would have gotten called. Wait a minute. Okay, somehow I munged two different files. Oh, here it is down here. So here's the send. So you can see us building the message, and we call connection send and send it out. And I'm not sure what happened to the handler. But essentially, whenever the body comes in, all I did was find the div with jQuery and extract the HTML IM body and just throw it back in there. Yep.
Connection supports all of type of alt type, SA, SQL, and
so the authentication, so you can do SASL anonymous, you can do digest MD5, you can do text plain, all of those. Some servers support SASL external, so you can do things like Kerberos authentication. Google uses it for token authentication with their own instant messaging stuff. So pretty much all of the SASL stuff you can do there. And then what's coming in the future, I want to do XPath matching with Strophe because the add handler thing has like 4 or 5 parameters and they're really restrictive. And I want to just be able to write XPath queries to be very precise with what kind of stanzas I want. And this is what it'll look like when it gets done. So this would be the message handler for you at foo.com and type equals chat. So that's much better because not only do you get to write this very specific query, but it's also sort of error checking it as well, right? So you can write a really specific query and then random messages won't match. Whereas with the handler code we have now, you have to sort of get all messages of a particular type. This is actually taking me longer than I wanted because none of the normal DOM XPath stuff works on partial DOM elements that don't already exist in a tree. And then there's the multi-session problem that some people are having, in that if you're running an XMPP connection in one tab and you open a new tab, now you have 2 XMPP connections, and you have to sort of keep them in sync. So we're working on extending BOSH with a thing for that so that all of the tabs sort of have the same state without doing any horrible hacks. And the code is available at code.stanzik.com/strophe. The second link is my blog. I write about this stuff a lot. There's more tutorials there on various XMPP topics and things like that. And my email address, if you need to get a hold of me, is jack@Collecta. Are there any questions?
I apologize if I missed the first part of the talk, so you already covered this, but could you explain what the difference is between what you just covered in Comet?
So Comet is only publish-subscribe semantics. So they're very similar in that they both allow you two-way low-latency communication. Comet defines the semantics of the communication as subscribing to some path, and then you get events for that path. That's possible in XMPP through PubSub, and also Presence works like that, but you can also do many, many other things and extensions over XMPP. So for instance, We can do I/O data. We can do file transfers. We can do lots of this stuff that's already baked into XMPP because people have worked on these extensions. Whereas with Comet, you would have to sort of make a new protocol over the publish-subscribe semantics to accomplish the same thing. So if you're looking for something really, really simple, and all you need is pub/sub, then Comet works great. I found that what happens is people start with something really, really simple, and then all of a sudden they want file transfers, and now they're designing protocols. And so it's easier to start with this because you already have all the protocols designed, because that's the hard work. Implementing a protocol is not too bad. Yeah, so for instance, the Major League Baseball chat, which has millions of concurrent users, is backed by a eJabberD XMPP server. So it scales pretty well. Yes? And just the other scaling topic is Google Talk has millions of concurrent users as well, and that's XMPP.
Can you elaborate a little bit more on the server? What is BOSH? Is that a commercial service that you would have to?
So BOSH is essentially, it's kind of like a web proxy server, except a web request comes in, it makes a TCP connection to an XMPP server, a two-way one, and holds it open, and then does the long polling translation between stanzas. So for instance, like you can see what this looks like in the log here. So the BOSH wraps it in this body tag. So here's this body, there's an empty body tag, but let me find one. So here's a body tag with stuff in it, right? And this body tag is just a simple wrapper. So the BOSH server will get this XML element. It will strip off the body. It takes the body tag, checks to make sure that some of the security stuff matches, so you can't spoof the connections and stuff. And then the stuff that's inside the body tag, it forwards over the TCP connection to the XMPP server. And then when stuff comes back, it just sends it to you when it has waiting requests to fulfill. So it's just a...
Does BOSH live on our server? Is it analogous to Apache? Is it behind Apache?
You can do any of those things. So because of the same domain policy, you usually have to reverse proxy a BOSH connection manager under the URL where you're serving index.html or wherever your app lives. With something like Flensed, you can do cross-domain by using the same XML HTTP request API, but using Flash's cross-domain stuff. And there are, so for our applications, we run our own BOSH servers. We proxy them under an Nginx, which serves static content, and we do that way. The Comet requires the same thing. You have a Comet D running that is equivalent to sort of the BOSH connection manager. It translates your incoming stuff into more stateful stuff on the server side.
So what's a local development environment look like? What do you run it in that stack?
That's a great question. So locally, you don't have to have an XMPP server locally because the connection manager, if you run one that's not built into an XMPP server, can connect to any XMPP server. You saw me, I just connected to Gmail, for instance. So I have a connection manager running on this local machine, and what I do for local development is I wrote a simple utility that will serve the current directory over HTTP, but also keep reverse proxy configurations. And I have a little text file in there that has a little configuration for where the reverse proxies are, which reverse proxies the BOSH. So I just type tape in a directory, and it sets up a local HTTP server just that I short-lived that serves the directory, handles the BOSH stuff, and that's how I do local development. And when we deploy it, there's usually an Nginx thing, reverse proxying the BOSH server, and serving static files, or in the case of Chess Park, there's a Django app on the back.
So it's the BOSH server I get from where?
The BOSH server I use and a guy on my team wrote is called Punjab, and you can find it at...
That's on your website.
Yeah. So code.stanzas.com/strophe is this library, but /punjab is our BOSH server. And the Speak site, which I showed you guys, is also open source, and that's available at the same site.
You said that BOSH was, I guess, in that acronym, it has synchronous in it. Does that mean that the AJAX call that you're making is literally the synchronous call?
No. It's still an asynchronous AJAX call. I'm sure they put synchronous in there because it made the acronym nice sounding. But it is synchronous in a way that the long polling is synchronous, right? You're leaving a connection out there on the server and you're waiting for a response to come back. But that's wrapped up for you in Strophe. So Strophe presents you a completely asynchronous API. You define event handlers, stanzas come in that match, and then they trigger events. Yes?
Will eJabber work as a BOSH server?
Yes, most of the Jabber servers include their own BOSH servers. The difference is there's a good side and a bad side to that. The good side is you have no serialization overhead. The XML comes in, it gets serialized for the server, and it goes all through the server, and it only gets serialized when it comes back out to you. With the normal BOSH server, you serialize it to the BOSH connection, it serializes it to the TCP connection to go to the server, and so there's an extra serialization step. What you lose is you can't connect to arbitrary XMPP servers. So if I can switch it to my eJabberdee's BOSH server here by just switching the URL, but I'll only be able to connect locally to that eJabberdee server. I won't be able to make a connection to Gmail, for instance. And it depends on the application which of these is right for you. If you want to support the federated network of XMPP users, so for instance on the Speak site, this is a requirement because we want people to be able to log in with their Gmail credentials and access their own Google Talk stuff. We don't want you to have a Speak.com account. But for other services, Drop.io and Yammer and stuff, they use anonymous connections, and they they do the authentication at a lower layer, or a higher layer, I guess. Yes?
One last question back on the XHR thing. So it is asynchronous. Are you getting partial responses back from the stream, or is every stanza its own full request, literal request?
You can send multiple stanzas, but you'll never get a partial stanza. The BOSH Connection Manager will only ever send you a complete stanza, and you can only send complete stanzas. But you can send as many as you want. There's also some neat functions inside Strophe. If you know you're going to be sending just a bunch of data from, say, a bunch of different pieces of code, for instance, at connection startup, which is pretty common, you can tell it to pause. It will queue up all of that stuff, and then when you hit start, it will send it all in one request. So you can sort of bootstrap the initialization stuff. Yes?
Can you make it work with JSON instead of X?
So you could. The thing that XML really buys you here is that there's no way to extend a JSON array. So say you have, this was all JSON, and I had a message stanza, and the 2 is a string. In XML, I can extend attributes by namespacing them, and I can extend any tag by putting a child in it and namespacing that. But you can only do that in parts of JSON. So you would have to have sort of a complicated extensible JSON format that you would use. So you would lose some of the simplicity, I think, of JSON if you went that way. Because it's really nice to be able to send those messages that are bodies. That's standardized, right? The body tag is not namespaced. But when I send a chess move, for instance, it'll be move, and they'll have XMLNS equals chesspark/move or something like that. And then I can put whatever I want in there. And the nice thing is the servers, if they don't understand what the data is, they just won't look at it, and they'll pass it all the way to the clients. So with JSON, you would have to sort of, I'm not sure how you would extend JSON in the same way, unless you decided to use all objects and no literals. Any other questions? Okay, thank you very much.